All right, now that we know how to do ratios, and hopefully you know how to do ratios good by now, we're going to go ahead and learn how to solve a proportion. Now first we have to understand what a proportion is. And to understand what a proportion is, you have to look at the two words that make it up. Proportion comes from two words. The first word is pro. And again, the word pro can have two different meanings. It could be like professional, like pro football means professional football, okay? Or it could be like favorable, like when you take a vote, pro or con. Pro means you're in favor of it, con means you're against it. And in this case, pro means in favor of. Now, a portion is a country word that means to be a part. Like, give me my portion means give me my share, give me my part. So it's a favorable part, or in other words, it's a fair share. But you have to be aware that in math, a fair share is not the same as a fair share would be in, say, for example, social studies. Because in social studies, we live in a democracy. So all men are created equal, so a fair share means everyone gets the same. But in math, a fair share is a lot different. Say, for example, if I and Brennan wanted to share a candy bar, okay, I weigh about 180 pounds. I wish I'm way more than that now. And I doubt Brennan weighs more than 90 pounds. All right, so if we were to share a candy bar, if we wanted a proportion, a fair share, then I should get twice as much as him. They go, well, that's not fair. And Brennan says, you just want more candy bar than me. But in math, that would be a fair share. And you go, how do you figure that? Well, first of all, the ratio would be 90 to 180. Brennan's weight to my weight is 90 to 180. And if I was to simplify that down, that would equal 1 over 2. Because 90 goes into 180 2 times. And again, 1 time here and 2 times here makes 90 over 180 the same as 1 over 2. So for every 1 piece of candy that he gets, I should get 2 because I'm twice as big. That's what a proportion is. It's actually equivalent ratios. And remember, ratios can be written as fractions, so that boils down to mean equivalent fractions. And we dealt with equivalent fractions when you were in 5th grade. If you remember, when we were dealing with equivalent fractions, we'd have a problem that says something like this. 1 over 2 equals x over 180. And remember, to solve and find the missing numerator, you divide and then multiply. So you would divide, 2 and 180 goes 9 times and 0 times, so it goes 90 times, and 90 times 1 equals 90. And again, that would be equivalent fractions, 1/2 equals 90 1/80. But it's also equivalent ratios. It says 1 to every 2 is the same as 90 to every 180. So when you deal with equivalent ratios, you're dealing with proportions, and when you solve them like a ratio, which you go, oh, well, that's going to be easy. It would be if all the problems were like that, but very few problems are like that, because most problems would look more like this. Say 5 is to 8 as what is to 23. Why can't I do this one like the one I just did? Because 8 doesn't go into 23 evenly. Now the truth is you could still solve it the same way, because even though 8 doesn't go into 23 evenly, 8 goes into 23. So if I divide 8 into 23, it goes 2 times 8 is 16, remainder 7/8. But now instead of multiplying 5 times 2, I have to multiply 5 times 2 and 7/8. And again, that would be 5 over 1 times 23 over 8. And again, can I simplify before I multiply? No. So 23 times 5 equals 115, and 8 times 1 equals 8. What's wrong with 115 over 8? It's improper. So divide 8 into 115, and it goes 1 time, remainder 3, and it goes, 4 times, remainder 3, and your answer is 14 and 3/8. So x equals 14 and 3/8. And you go, oh God, Mr. Do, I hate working with fractions. Do I have to do it this way? And the answer is actually no, you don't. You can do it this way and work with fractions. Or if you like, there's a different way to do it. Because I don't know if you remember in 5th and 6th grade when we dealt with fractions, we also talked about how you could compare fractions to see which one was larger or smaller. And to compare fractions to see which one's larger or smaller, you multiply one denominator times the other numerator to see, which side equals the biggest answer is the larger one. But since these are equal, that means this times this has to equal this times this. By the way, when you move on to high school, that's called the product of the means is equal to the product of the extremes. And again, I don't know where that comes from. Maybe your high school teacher can explain why they say that. But all it means is if you cross multiply these two, it has to equal these two cross multiply. So if I multiply 8 times x, I get 8x. If I multiply 23 times 5, I get 115. And now I have a simple one-step equation. How do I get rid of multiplying by 8? I divide by 8 on both sides. That'll cancel, giving me x. And when I divide 8 into 115, it goes 1 time, remainder 3. It goes 4 times, remainder 3. And what do you know? You still get 14 and 3/8. So whether you do it using fractions when it doesn't go evenly, or whether you do it as a simple equation by cross multiplying and set them equal to each other, is up to you. Personally, I think this is the easiest way to do it. But it's up to you which way you do it. Again, if you want to do it with equations, you cross multiply one denominator times the other numerator, one denominator times the other numerator, and you set the two products equal. And then you solve a simple one-step equation. And I think that's the best way to solve a proportion for your homework tonight.